Okay, continuing with probability. If you're doing an experiment, then the set of all possible outcomes of that experiment is called the sample space. I'm sometimes going to refer to that as SS, the sample space, the set of all the possible outcomes. Each individual element in the sample space is called a sample point, or a simple outcome, or a simple event. So for example, here we have the experiment tossing a coin. The sample space would be the two possible outcomes, the set containing H and T for heads and tails. Now, drawing a card, this one I'm not going to write out. There are 52 cards in a deck of cards, so it would go maybe Ace of Hearts, Ace of Diamonds, Ace of Spades, Ace of Clubs or Clovers, and then it would go to 2 of Hearts, 2 of Diamonds, 2 of Spades, 2 of Clubs, and 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, and then King of Hearts, King of Diamonds, King of Spades, King of Clubs. So that ... means continue. There are 52 total in a deck of cards. Again, I just don't want to write them all out. Rolling a die, that one's nice and easy. It's just a cube. A cube has 6 sides. The numbers 1 through 6 are on the sides, so the possible outcomes are 1, 2, 3, 4, 5, 6. Now, tossing a coin twice, well, it could go heads, heads. It could go heads, tails. It could go tails, heads, or it could go tails, tails. Those are the 4 possibilities. Notice I didn't say it could be 1 heads and 1 tails. I'm very specific. The first one could be heads and then the second one tails, or it could be the other way around. So there are 4 total possibilities when you toss a coin twice. Now, the next vocabulary term is an event. An event is a subset of the sample space. Any subset of the sample space is defined to be an event. It can be a single element. For example, in rolling a die, it could be the 4. Or tossing a coin twice, it could be TH, tails on the first, heads on the second. That's one event. It could be several elements, or all of the elements, or none of the elements. That would be the empty set if it had 0 elements in it. So the experiment for number 8 is to randomly draw a number from 1 to 10. If there was such a thing as a die that had 10 sides, it would be rolling that 10-sided die. So the sample space, since we're just going to get one number from 1 to 10, I'll write them all out rather than using the ... notation. That's the sample space. Well, the event of drawing a prime number, this is our sample space, so the events are going to be subsets of this. And the event of drawing a prime number, well, it is a set, it's a subset of this, so we have to use squiggly brackets. We have to choose all of the numbers in this list that are prime. Well, the lowest prime is 2, and then 3 is a prime, 5 is a prime, 7 is a prime, 8, 9, 10, and that's it. Those 4 numbers are the prime numbers, so that's the event of drawing a prime number. Again, this is the numbers 1 through 10. This is the prime numbers from 1 to 10. The event of drawing an even number, well, that one's nice and easy. 2, 4, 6, 8, 10. So, If we were to randomly draw a number, we're going to do that experiment. Let's say the number 5 came up. Well, I would say that this event occurred because one of the elements in this set occurred. 5 is a prime number. It is not an even number, so this event would not have occurred. How about the event that a 2 occurs? Well, let me rephrase that. If in the experiment, the number 2 was drawn, that means this event occurred, and also this event occurred. So more than one event can occur at the same time. These both have the element 2. So if a 2 shows up, we say both of these events occurred. Okay, number 9. Suppose that, this is kind of a more theoretical, I'm not using numbers anymore. Suppose the sample space of an experiment is this. So as an example, in our previous experiment, these were the numbers 1 through 10 as the sample space. But this n could be 100, so this would be 100 events, or it could be 6, and this could be 6 events. Each simple event is assigned a probability, and this is the way we write probability. This is a number. Capital P means the probability that this event occurs. So the probability of an event is the sum of the probabilities of the simple events that make up that event. So for example, this event has three simple events making it up, E1, E3, and E7. So the probability that E occurs, the event E, is the sum of the probability of each one. Probability of E1 plus the probability of E2 plus oops, I said that wrong, and I wrote it wrong. The probability of E1 plus the probability of E3 plus the probability of E7. Just add up the individual probabilities. Each simple event has probability from 0 to 1, inclusive. Inclusive means it could equal 0 or it could equal 1. So, that is the probability of any event, EI, is in between 0 and 1. In between them. Greater than or equal to 0, less than or equal to 1. The same holds true for any event, like this event, capital E. This has a probability, P of E, and it's in between 0 and 1. Lastly, for this video, the sample space is in itself an event. Why is that? Well, I said that any subset of the sample space, here's the sample space, is an event. Well, if I took this whole set, E1, E2, all the way through En, that is a subset. You remember, just remember this. Every set is a subset. That's how I write subset. Every event is a subset of itself. Every element in S is also in S. So, therefore, if you want the probability that S occurs, that's the probability that one of these events occurs. And it's guaranteed because these are the only possibilities. The sample space is the set of all the possible outcomes. So you are guaranteed that it's going to happen. The probability that something occurs is going to be 1. You could also write that 100%. And in the experiment of rolling a die, you have 6 outcomes, 1, 2, 3, 4, 5, 6. That's like saying, well, what's the probability that either a 1, 2, 3, 4, 5, or 6 shows up? Well, 100%. That will happen 100% of the time.